So, multi-dimensional arrays. We've talked about arrays, and if you recall, an array is like a list. And let's pull up the visualizer. So, if you recall, it's like a list. Let's say int numbers equals new int size 5. And I'm going to say numbers at index 0 equals a random number. Numbers at index 1 equals another random number. Those aren't very random. Numbers at index 2, let's actually try a random number. Numbers at index 3. And then finally numbers at index 4. Again, remember, the index always goes from 0 to the size or the length minus 1. If we visualize this, recall, it's like a list. So we have a list of numbers. You can do the same thing for strings. You can do the same thing for doubles. Basically, an array is like a list. Again, we can access this list based on the indexes, and we can modify the list based on the indices as well. All right. Remember, an array list is similar to an array, except it can grow and shrink. Okay. Those are the main differences. A multi-dimensional array, on the other hand, if you think about an array as a list, it's one-dimensional. It goes from 0 to n, where n is the total length of that array. A multi-dimensional array, specifically a 2D array, is more so like a table. You have an x-axis and a y-axis. You have rows and you have columns. Okay? And it's an array that contains other arrays. All right? So if this is a typical array, an array list, on the other hand, it's very similar to this. So we do double braces. That tells that it's going to be a two-dimensional array. Right now, I'm making it 5 by 5. So if I have 5 rows by 5 columns, can anybody tell me how many individual cells I'll have?
25.
25, exactly. So I have 5 rows by 5 columns. And if we visualize this, if you recall, a two-dimensional array is an array of arrays. So each index in our first array points to another array. Each index points to another array. Each index points to another array. So here's our numbers variable. It points to an array in memory. Each index inside this array that it points to another one, right? Each one of these being size 5. Right? Now that is the actual representation of an array. I'm sorry, a 2D array. But conceptually, in your mind, you can visualize it as a table, okay? Its actual implementation is an array of arrays, but conceptually in your mind, you can think of it as a table. We talked about one-dimensional arrays. This is how you would create that one-dimensional array, and it would have 5 indices. Int points equals new int 5 indices. Then we add some points. So point 0 equals 22, points 1 equals 10, 15, 45, and 30. Everybody with me so far? Again, we can calculate the scoring average, right? We just sum up all of these points, divide it by 5. We can find the highest point. We iterate through this array and find out which one is the biggest number, basically. We can find the lowest point scored. We iterate through the array and find the lowest number. But what if we want to record the scoring of 4 more players, right? We could create 4 more arrays, one for each player, or we could use a 2D array where each row would represent a different player. Everybody with me? So instead of creating 5 individual arrays, we would just have one 2-dimensional array where each row represents a player. Okay? Are you with me? So, again, we have int players, or int score, equals new int. They had 5 scores. So I'm going to just do rand equals new random. I'm just going to randomly generate some numbers. For int I equals 0, I is less than scores dot length, I plus plus. Scores at index I equals rand dot next int. That should give me a random number between 0 and 49. Let's do 1 and 50. They scored at least 1 point. That's not true, because some players score no points. So this will give me a number between 0 and 50. Import java.util.random. All right, let's visualize this. Basically, I want to go through my array, and then each time they scored some points, I added to the array. You know, if we were doing this for an actual player, we would look at their actual point score total. But right now, I'm just randomly generating this. So this player scored 2 points in game 1, 46 the next game, 14 in the next game, 38 and 36. Right? Not bad. So that was their point totals. So now if we had, let's say we have 4 more players we want to track. We could call this player 1, player 1, player 1. This array keeps track of player 1. You could do the same thing, except this one is going to be called player 2, and we don't need to recreate this random object. Player 2. We could do the same thing again. Player 3, 4, and 5. All right, we want to keep track of 5 different players, so we create an array for each one. We can just as easily do this. We visualize the code, hopefully it doesn't run out. So player 1, we have an array. We're going to populate it with some numbers. Player 2, we have another array. We're going to populate it with some numbers. Player 3, same thing. Player 4, same thing. And then player 5, same thing. All right. So we have 5 different players. So we create 5 different arrays. Makes sense. But if you recall throughout the entire semester, I've always pushed your programs must be dynamic. You don't want it to be static like this. I created all 5 of these arrays because there's only 5 players. What if there are 15 players? What if there are 50? What if there are 100 players? Well, we don't want to write the code for 100 different arrays. That's inefficient, not only for your program, but for your time as well. Nobody wants to sit there and spend 3 hours writing the same code over and over again 100 times. That's boring. So what we would do is, instead of doing this all in individual arrays, we would just create a two-dimensional array and populate it that way. So if we know each one of these players, we're tracking 5 games. 5 games. And there are a total of 5 different players. So if you think about that, there would be 5 rows and 5 columns. So again, how many total cells would that be?
It's 25.
25, right? There are 25 total cells that we have to create. So to create a two-dimensional array, I'm going to delete all of this. I'm going to say players. To create a two-dimensional array, what you do is first you type your data type. I'm just going to erase this whole line actually. I'm just write this over. First you type your data type. So I know this is going to be integers because it's going to keep track of their scores. Then you do a brace, opening and closing brace. That tells it it's going to be an array. Then you do another opening and closing. That tells Java it's going to be a two-dimensional array. All right. Hit a space. Whatever you want to name this, I want to name it players. Equals new data type again. Open brace. How many rows do we want? That's a question for you all. How many rows? How many players?
5 players.
5 players. And then how many columns do we want?
5.
5. 5 by 5. All right. 5 by 5. So now we have our two-dimensional array. Creates a 5 by 5 two-dimensional array. So your next question is what we'll cover again next week as well. How do we access this two-dimensional array? So if you recall, we access array like this, right? We want to set index 0 equal to 45. That's how you do it with a typical array. With a two-dimensional array, the first number specifies which row you want to access. Another brace specifies which column inside that row you want to access. So I'm going to do this again. Players, I want to access row 0, column 1 equals 3. Players, row 0, index 2 equals random number. Players, row 0, index 3 or column 3 equals another random number. And then players, row 0, index or column 4 equals another random number. So again, this first number right here specifies which row you want to access. The next number specifies which column in that row. So let's visualize this. We create a random object. And you recall again, our array in memory is an array of arrays. So players points to an array. That array, each index points to another array. So index 0 points to this array over here. Index 1 points to this one. Index 2, this one down here. Index 3, this one down here. Index 4, this one down here. Okay? So when we get to this line right here, which one of these arrays do you think it's going to modify?
The first one on the top, on the right.
Yep. So what it's going to do is it's going to go to players, go to row 0, and then index 0, 0. So it's going to set this right here equal to 45. We do this again. Players at index 0, we go there, we follow that arrow. Index 1, we're going to set to 3. Players at index 0 again, we follow that arrow. At index 2, 83. Players at index 0, we follow that arrow again. Index 3, 22, 14. All right. So,
Does that mean it's switched then? Does that mean that, I mean, if you go back to the visualizer, it's saying like those are so like that's how we can look at it, right? Those each array right there, those are each a row, right?
yeah. So this
So
right
does that,
here is essentially this will be your rows, and then these will be your columns.
I just yeah, all right. I just want to make sure. So like, but like that's if we looked at it on a chart, each player has a different score, right? That's not all one player score.
So
You know what
this
I
would
mean?
be one player right here.
Oh, it is.
This would be one player, and then this array down here would be another player. This array would be another player. This array, and this array.
You said the first bracket of the like of the arrays is the rows, right?
Yes, that's the row, and then this is the column.
All right.
Mhm. So basically, if you think about it as a table,
Because like the way that I'm looking at it right now, it's like we're staying in the first column. You know what I mean? We're not going up and down. And like, no, I got it. I'm thinking about it the wrong way. I see what you're saying. Right.
so if we think about this as a table, right, this is what the table would look like. It's 5 by 5, right? Then let me make the font a little bit bigger. So if we look at this again, a different way of looking at it as compared to the visualizer, we're talking about row 0, index 0. So right here, row 0, index 0 would be 45. And I'm going to change the layout of this table. Give me a second real quick. I'm going to change the table a little bit. All right. So again, if we look at this as a table, so this says row 0, index column 0. So row 0, column 0, 45. Row 0, column 1, 3. Row 0, column 2, 83. Row 0, column 3, 22. Row 0, column 4, 14. Is that sitting in with everybody? All right. So if we go through this again, players index or 2, 4 equals all right. So if we do this, we already did these first 5. All right. So if we do players 2, 4, again, this is the row, this is the column. So players at 2, index 4 would equal 34. Players at row 4, index 2 equals 65. Row 4, index 2, 65. Players index 3, 3, 32. 3, 3, 32. Is that making sense? All right. Okay. So now let's generate some random numbers and let's set our indices inside this array equal to that random number. So if you recall, we iterate through an array for int I equals 0. I is less than players.length I plus plus. That's how we iterate through an array, correct? Yes, no, maybe.
Yeah.
Yeah. So that's how we iterate through an array. And then we normally would say players at index I equals whatever, right? That's just some random stuff. Ran.next int. Okay, that's how we typically would do it. But seeing as how this is a 2-dimensional array, if we did this, we know each index in our players array in memory points to another array. So we can't set it equal to a random integer because it's a pointer. So we have to access both. We have to get the row and the column. So we have to loop through all of them, both rows and columns. So to loop through a 2-dimensional array, what you want to do is int I, instead of I, let's use row. Int row equals 0. While row is less than players.length, what that gets is the total length of our players array. How many rows does it have? Then we want something called a nested for loop as well. It's nested because basically it's nested inside another for loop. So for int call or column equals 0. Call is less than players, whatever row we're at, dot length, because we know it's an array of arrays. Call plus plus. All right. Now we can say players at row call equals ran.next int. So we're getting the row and we're getting the column, and then we're setting it equal to a random number.
I got a question real quick about the. So that's saying, I understand the nested for loop, but it's saying, you make a variable equal to 0, and then you're saying while the column variable is less than the index player's row index.
So if you recall, if we visualize this, Come on. If we look at this in memory again, we see each index in our players array points to another array. So right here, what we're saying is while column, that number column is less than players at row, let's say 0, is less than the length of that array. So we're iterating through the row part, the row variable iterates through this array right here. So it goes from 0 to 4. The column will iterate through this array over here, and it goes through from 0 to 4 as well. So we go through this, and we're going to look at it like this. I like to look at it as a table. Come on. So we go through it. Row starts off at 0. Column starts off at 0. Generate a random number. Okay, let me redo that. Let's do it between 0 and 25. All right, again, row starts at 0, column starts at 0. Then we do a random number, 14. Then we set players at row by column equal to 14. So that line right there will change row, players at row 0, column 0 to 14. And then we increment column by 1. So then we would generate another number, 19. Right? Row 0, column 1. Row 0, column 1.
So if you don't write that players the row index that length, it's gonna increment the row as well. Or like that's what I was concerned about. Like it would go 0 0 1 1 2 2, right?
So if I don't do this right here, players at row dot length, what will happen is if I just do players dot length again,
It'll do like the 0 0 index, then it'll go to 1 1 index, right? It'll skip over a whole column, right? Or
not necessarily, you may run into an issue. Let's say these are not equal. The rows and columns are not equal.
mm,
Let's say I have more rows than I have columns. If I just do this, players dot length, column will go from 0 all the way up to 9. But we don't have 9 columns, so you'll actually run into an error,
oh, okay. I got you.
right? So you'll actually run into an error. So let's do this again. I'm just gonna repeat this. The first one is a 1. Row 0, column 1, it's a random 1. And then number was 1 again. And then actually, what's going on? Okay. This one was a 2. Now row 0, column 3, random number was a 9. This time the random number is a 10. And now what happens is column now equals 5. Well, that's no longer less than, that's equal to how many columns we have. So it's actually going to break this loop, go to the first loop, and increment row. So now row equals 1. So now we're on to the next row. Starts column over at 0, and then we go through. Row 1, column 0 equals 23, Jordan year. We go through again. Row 1, column 1 equals 24, RIP Kobe. We go through again. Row 1, column 2, 24 again. Go through again. Row 1, column 3 is a 2. Go through again. Row 1, column 4 is a 9. So this is how you would iterate through your two-dimensional array. And I'm setting each row column equal to a random number. We increment again, column equals 5. That's no longer less than, it doesn't satisfy this condition, so it breaks that loop, goes up to the top one, increments row by 1. Now we're on the second row, or the third row actually. Starts column over again, 18. 21. 10. 0. 14.
Last question. I just want to make sure I understand that player's row. So that's saying while column is less than the length of the row, like if like you said, like the row is 5 indexes or indices, while column is less than that, execute that code.
Right. So while column is less than, right now row is 2. So while column is less than the length of row 2, so 5.
So you're doing that variable row holds like I just got because like I know we didn't do that with the array. Like we just did players dot length. So that row variable tells us that it's it's hard to explain, but I get what you're saying, but I just want to make sure I understand.
So what we're doing is this line, this code right here, just this right here, it gets us the entire row 2. It gets us that entire array. So all of this right here, it'll return this whole thing. So basically you could think of this line as just getting an array. We're just accessing it through our 2D array. So players, the array at players index row, which is 2, what is the length of that array?
Okay, because you said it points to another array. I got you. All right.
Right. So this one up here, when we just do players.length, we're saying, okay, what's the length of that first array? Technically, how many rows do we have? Right? How many rows do we have? This one, so if we're at row 2, what's the total length of row 2? Well, the total length of row 2 is 5. Right? That makes sense?
I got it now. Thanks.
All right. So let's keep going. Again, column now equals 5. So it's going to break this nested for loop, go up to the main one. Row equals 3 now. So we're on the 4th row. Column resets to 0. Random number is 12. Next random number is 24. Next one is 13. Next one is 23. And 22. Again, now column equals 5. That doesn't satisfy this condition anymore, so it breaks that nested loop. It goes up to the main for loop and increments row to 4. So now we're on the 4th row. We go down, column resets to 0. The random number is 8. Then 6. Then 12. 16. Finally 18. Goes back up. Column is incremented to 5. No longer satisfies this condition. It's equal to the length. It's not less than anymore. So it breaks the nested loop. Row is incremented to 5. It equals the length, right? It's no longer less than, so it breaks that for loop, and our program ends. Does that make sense? to everybody, even the ones that are on their phone. All right. And even to the ones that aren't paying attention. Does it make sense? Because I ain't going over it again. All right. Okay. Everybody sure they're good? Okay, so let's look at the lab for Friday. So on Friday, I want you to write a program that returns the sum of all the elements in a specified column in a matrix. Okay? So I want you to create a matrix, enter a 3x4 matrix, row by row. That's what you want to ask the user to do. All right? They're going to be creating a 3x4 matrix. So you know you're going to have 3 columns, 3 rows and 4 columns. So the user will type in the first row, so 1.5, 2, 3, and 4. Hit enter. They'll type in another row, then the last row. Okay? You with me so far? And then what you'll be doing is you won't be summing up the row, you'll be summing up each column. So column 0, 1.5 plus 5.5 plus 9.5. Then column 1, 2 plus 6 plus 9 plus 1. Then column 2, 3 plus 7 plus 3. Finally, column 3, 4 plus 8 plus 1. All right. So that's what you'll be summing up, the columns, and then printing those out. Okay, so have those brain gears churning right now for what we'll do on Friday. Hopefully you all look at it and attempt it by Friday and don't come in with a blank JGrass file. Any questions about Lab 12? Okay. Assignment 12, on the other hand, you'll be creating a 5x5 matrix with random numbers. You want to populate it with random numbers between 0 and 9. This is very similar to what I've done in class. Then I want you to loop through your array and sum up each row. Okay? So each row will be summed up, and then you'll print that out. So for example, my program, I randomly generated the numbers, and here is my matrix. Here's my 5x5 matrix. The first row had 2, 0, 4, 8, and 2. The next row had 3, 8, 2, 7, 4. The next row, 3, 9, 1, 7, 4, and so on and so forth. So this is my 5x5 matrix. Row 1 summed up equals 16. Row 2 summed up 24. 24, 24, and 31. So some of you all can rejoice because you're not reading anything from the console. You're just randomly populating a matrix with random numbers between 0 and 9. I want you to print out that matrix and sum up each row. All right, so the lab and the assignment are very similar, but they are different. The lab you will be reading in from the console, whereas for the assignment you won't be. You'll be randomly generating the numbers. Any questions about the lab, assignment, or two-dimensional arrays? I will post this video by Friday, so be on the lookout for that.